When Guru was arranging the order of the panel, and he asked me he grouped Malik and I together to talk from a technology vendor's perspective. So although I didn't see Malik's slides beforehand, but it turned out it played out pretty well. So while Malik is talking about from service provider network point of view, what the SDN's impact and transformation will look like, I will talk primarily I will be primarily focusing on enterprise networking and the large cloud environment networking. So with that, I'll quickly cover a few topics in the next 10 minutes or so. The first one, I'll talk about what are the drivers from Dell's perspective to the SDN movement, and what's our long-term view towards SDN. I'll also talk about a few market opportunity examples, and those are from our business vantage point. Some are very immediate short-term opportunities. Some are long-term directionally market transformation. I'll touch on those, and then I'll introduce a little bit of what we do now about SDN in terms of the programs. So if we look at from an enterprise and large data hosting center point of view, the driver behind today's changing of paradigm of networking is primarily because this computing model that the network is built to support is fundamentally changing. So it changes from the client-server model into this cloud centralized type of model. And the technology drivers behind it, there are multiple of it, but the main one of the main ones is the virtualization. So with the computing model changing from the client-server model of the last 15 to 20 years into this new cloud type of model, we see the impact on the networking side are very profound and in multiple areas. So first, in the data center environment, we see that because of the arising of the virtual networking from the hypervisor environment, and that triggers the server and an access level layer switching becoming a converged type of infrastructure. And secondly, that triggers a flattened architecture of the aggregation and core network. And then about network services, you can deploy them anywhere at any time in the form of virtual machines. That fundamentally changes the data center networking architecture. Now, campus networking, not many people talked about that, the disruption coming yet, but one can easily see the unification of a wireless or wireline type of access network. Today, with the wireless network, from day one, the separation, the data plane and the control plane are separated, but on the wired side is not the case. And that gives a lot of a challenge to both the user mobility and the workload mobility. So we'll see that that architecture barrier is soon to be gone. Thirdly, with very large scale out computing systems coming to the horizon, and also very large warehouse scale data center, homogeneous type of data center environment, that demands a new class of switching, and which is not addressable by today's enterprise class switching architecture. So that's another huge opportunity to be presented to us. And we believe software-defined networking can be a key player, key enabler in all of those areas. And I'll touch on some of the detailed use cases and business opportunities briefly. The first one as we see it, SDN and OpenFlow enabled opportunities is pretty much in the data center environment, a multi-tenancy data center environment. And this is probably one of the low-hanging fruits from our point of view for SDN and OpenFlow architecture. And different people have different studies, but to us, we have some internal study, and based on customer feedbacks and our internal market research, we saw that a SDN-enabled multi-tenancy data center can reach to, say, $1.6, $1.7 million market. That's just addressable to Dell and, in about 4 years. And granted, that's not purely networking. It is infrastructure. It is management, automation, software on top of it. But this is just one small use case of SDN OpenFlow enabled. I won't go through the details of why SDN has certain advantages in this space. I think throughout the 2 days of the conference, people have touched on many aspects of that. So different people look from different angles, but you can pretty much see the reason for the SDN-enabled multi-tenancy data center being simplicity of management, ease of control of network services, better security, separation of different tenants, and so on. So, and it can also interoperate with the legacy environment. So, switch the switch out there. So, but this is a very tactical, very short-term, immediate, low-hanging fruit market opportunity. Just to relate to the theme of this panel, but we can see many more and many other more strategic areas, which I actually will pick two to touch on. This one is about enterprise networking, campus networking. Today, as I mentioned a little bit earlier, that we have very siloed operational procedures to deal with a wired network and a wireless network, WLAN specifically referring. From access control, security, management, and the policy, QoS perspective, they are totally different. The fundamental reason for that is the WLAN side was designed from day one with a separated architecture. A data plane and the controller plane are separated. And it's somewhat like the SDN concept from day one already. The campus networking, the wired campus networking, however, was the legacy of the data networking from 15, 20 years ago. We built very monolithic access switches that blends the access, data access, and the control protocols together. So think about a common policy, security policy, access control policy you want to apply to both sides of the world. It's not that simple. Now, we see the potential of uplifting or elevating the control point from the campus data network onto a higher plane, like either a centralized control plane or a cloud unified control plane, together with the wireless side. And this is a much elegant architecture, and it will also triggers a set of a new access switching class. So think about APs today at the wireless environment. The economics of APs are totally different than access switch, the wired access switch. So we believe there is a huge potential. How long it will get there is probably a long journey, but what I'm painting a picture is that probably 5 to 10 years from now, you will see the campus networking becoming a new class that's next generation AP-like access class for the wired side as well as for the wireless side, unified by a common control plane up in the cloud or some centralized position. Another example, also directional example, and this one it's more applied to the hyperscale data center environment or extreme scale-out compute platforms. Today, with the advance at the silicon level, it's not uncommon to see large scale-out systems with thousands of CPU cores, a single system, or in a very large warehouse scale data center, cloud-based data center, you see hundreds of thousands of CPUs performing a single task or designed in a very disciplined way, in a very homogeneous way to support a single or a few well-defined applications. In that environment, the communication needs are very, very different than today's enterprise class switching category can support. If you look at the picture on the right-hand side, the middle ground, what I call fabric, is a new category that's emerging. Up to now, most of the compute systems or the infrastructure is designed that the left-hand side, the servers and the storage, attached storage, interact directly with the network. So you will have either in-system, in-server interconnect to support the in-server communication, or you need to go out to the external switching to perform inter-cluster communications. Now, with the emergence of this hyperscale environment, you see the need of shared but perceptionally local storage. Say, think of a RDMA type of environment, and as well as no difference from a virtual machine point of view to migrate from one cluster to another, whether you perform that inside the same rack or at another CPU at another rack. So this new class of fabric switching in the middle has a different characteristics than today's server interconnect or the external switching. It does demand very low, ultra low latency. It does demand very predictable switching guarantee, non-blocking like. But it also have certain aspect of today's external switching characteristics. So this is a new class we believe will soon emerge in the next few years. And this is a beautiful, beautiful opportunity for some form of SDN, or I don't know whether today's open flow can be applied, but characteristically, simple manageability, very dynamic control of workload redistribution is one element of this class of switching architecture. We believe this is a huge market opportunity that's going to emerge very soon. So what I have gone through are a few examples of Dell's point of view towards SDN from a commercial point of view, market point of view, both short-term and long-term, the impact to enterprise switching and cloud switching. But to summarize, what is Dell's business point of view towards SDN? We believe that the shift in the computing paradigm requires a new fundamentally new architecture and deployment approach to networking industry that applies to breaking up of today's monolithic network architecture, that applies to the breakup of today's operation model, as well as to break up today's development model, that a single company controls everything. We believe the SDN will enable a much more collaborative ecosystem-based development environment. So from Dell's point of view, we support open flow-based SDN as the starting point towards this SDN movement, and we are happy to work with partners and customers towards this new direction. Thank you.